So I would like to kick off the summit with some discussion about AI and robotics in particular. So if you think about robotics, right, especially in the consumer space, we all imagine something like this, very advanced, very cute, super helpful. But the truth is, if you look at the market today, in fact, the only thing that get mass adoption is the vacuum cleaner, right, the Roomba. If you even can call it the robot. For all the other type of robots, the cost is way too high for the value that they really bring to the consumer. So for example, Pepper is the robot from SoftBank. The cost is about 80K, and it's unclear what Pepper can do, even though it has a lot of motors, has a lot of different functionalities. It can dance, but you don't want to buy a robot just for dancing for 80K, right? So the truth is there's $1 trillion opportunity there for us to unlock. And so how do we do that? Well, if you think about it, right, robotics development is actually very challenging. It requires many deep expertise in different fields, from electrical engineering to mechanical to AI. And there's a huge lack of collaboration between projects. There's no standards, as well as there's no incentives for people to work together. And you need to depend on manufacturing, which is very slow and costly. And so the end result is we have a lot of silo projects within a few big corporations that have the technology. And a lot of effort is wasted because of duplication. So the solution is we want to build an open platform for AI and robotics, kind of like Android, Linux, with that massive global scale and impact. But we want to avoid the traditional open source challenges that these problems usually get. For example, it takes a long time for a project like Android, Linux to really gain the momentum. And it's also a lot of problem with free rider, or how do you incentivize people to move first. So our solution is to building this on blockchain and tokenize it using game theory to really build backed in on this incentive. So let me talk a little bit about game theory. So game theory has been instrumental in AI, especially multi-agent system for a while, right? But do you know that actually game theory has been playing a very big role in machine learning as well, in adversary learning, right? You come up with a two program using AI to play games, and you just play them off each other, and allow them to learn during the course. It has been making a lot of progress, especially for Go, right? With the new Go program, they were using the adversarial search. So a little bit about game theory, for the people that you haven't heard yet. So here's an example of game theory. So this is like a normal form game. It's called Prisoner Dilemma, right? There are two players. Each of them can choose an action. The column player can choose either left or right, and the row player can either choose top or bottom. Either C is corporate and D is defect. Prisoner dilemma is like, if you have two prisoners and you get investigated, right? If they both collaborate, lying, to the investigator, they both get off. And so they both get really good payout. But if one lying and one cooperate, then the one who is cooperating would actually getting much worse, right? Just like, when the investigator get to put someone in jail for a long time. And so the bottom line of this is, the outcome is always that both of them will cheat, will defect. So that's the Nash equilibrium. Can we do better though, right? And the answer is actually yes. If we model this as the repeated game. So if you don't think of the collaboration between the two players as one shot, but it's a repeated process, you keep doing that over and over again. In fact, there is a strategy here that allows us to enforce collaboration between the two sides. So this is fascinating because now we have a tool, right, to really incentivize people to do what we want them to do. So I won't go to exact detail, but because of this, it allows us to actually come up with a new system, align all the incentive of the players to make sure that we all collaborate in this new platform. So imagine, a world in which there are many different use cases people want to build for robotic. And instead of having to develop everything from scratch, they can just go to our platform and really pick and choose different components and start building these use cases, whether it's plant watering robot, whether it's food delivery or laundry folding. So all of this will become a possibility with this collaboration of how we can put the technology together. So our platform has many different components, but at the core of the platform is a code base, which is kind of like an open, like Linux or Android, in which people can contribute code, people can check out code and develop on top of each other work. And then we provided with two very important pieces, which is one is the manufacturing alliance that help people to prototype and really manufacture all these components. And then we build a marketplace on top of it so that we can connect the two sides, the corporate and the developers. Think of it like Uber for robotic and AI technology, right? Uber is the largest hotel company in the world without owning any hotel rooms, right? And then, largest taxi company in the world without owning any car. And then Airbnb is the largest hotel company in the world without owning any hotel. And so for Kambria, we want to build the largest AI and robotics company without actually owning any developers, right? Creating this platform to allow people to connect and develop technology that will satisfy the requirement and the use cases. And then last but not least, we're building protection of the IP and app store so that people can acquire and buy this technology very easily. There are many pieces in the platform, but you can think of it as, here's a slide of how the things flow. So companies can use Kambria to get robotic solution, to pay licensing fee, to incentivize developers. And then developers, on the other hand, can put out proposal and solution to satisfy all this requirement. Once the technology is being used to provide services to the user, the payment going back would then get shared between all the contributors to the platform. And by contributor here, I mean many different ways, right? Not just the technology, but also maybe data. We can pay people to contribute data so that we can learn different algorithms. And so that's the way that we want to push forward, having kind of this crowdsourcing of training material, of technology, of data, so that we can build the best AI and robotics components. There are many different advantages to our platform. For example, we can bootstrap the community very quickly by using this incentive of tokens, or really get a network effect because we have the two sides of the platform, right? From the business side as well as the developer side. New technology developed by one team can be used by many teams to unlock new market. And then we also incentivize sharing and openness using the token and the incentive that I mentioned earlier about how to put a game theoretical approach to this platform. So how do we imagine things will flow? So we're starting out with the telepresent robot, and we're working on adding different components. So for example, speech allow the robot to be able to interact with the user using voice command. Navigation, how to let the robot navigate, move around indoor without any intervention of human. And then computer vision, how you recognize object in the real world. And then adding an arm on top of that would allow the robot to pick up objects and move things around. That's when we unlock many different doors, right? Literally and also figuratively. And at the end, that's what we envision for Kambria, to building many different use cases of robot in the world. So two sides of the problem, right? Community side is absolutely crucial to us. So how do we build out the community, developer community? We're starting out by building robotic labs around the world. We're already working with Carnegie Mellon, Stanford, JVN in Vietnam, NTU, to really selectively bring in all the technology that can fit together to provide a complete solution for robotic applications. And then we also bring in existing open source project like ROS. ROS has about 200,000 developers building up operating system for robotics. And also we're organizing a lot of hackathons in major tech hubs, focusing on social impact mission. For example, trash picking, cleaning up the city, or senior care. These are the things that we feel compelling, that will allow us to create this movement of AI and robotic development for social good. And then on the business side, we have 3 types of business partnerships. The first one is to work with big corporations who really want to bring in the new technology to improve their existing services. So for example, Home Care Assistant and Humana are the largest senior care or home care companies in North America. So now they want to use our robots so that they can provide and deliver care services directly to the home. Or Topan. Topan is the largest printing company in Japan. Really interestingly, they want to build an AR and VR robot so that people can attend the Olympics, the Japanese Olympic, the Olympics in Japan in 2020. So this is actually very, very exciting. First, time in history, then people will be able to attend a big event through robot. Second direction is we want to work with companies to really develop new technology to tackle this market. Telemedicine is a big potential field. There are a lot of attention paid to this field because as the population grows and the demand for healthcare providers really growing, we need new technology to help us pick up this slack. And then last but not least, we're creating this new marketplace so that companies can share and commercialize their technology to the development community. So where are we so far? So basically, we have built the best programmable and customizable telepresence platform in the world. We deploy and sold a couple hundreds of them worldwide. But one really interesting thing is we came up with a new process of manufacturing. So we, in fact, 3D print all the parts and assemble them all in California. This allows us to move with record speed and also very low cost. So let me show you some of the new technology that we developed just to change the pace. Let's see whether I can play this. So this is the prototype of our platform. This is the robot that we're selling in the market, and these are the arms that developed using 3D printing. And this arm can be teleoperated remotely using a VR headset. And so you can see my co-founder in the background, and he's using a VR headset to move the arm very seamlessly. So this is all done through the internet. And a similar arm like this in the market is being sold about $10,000. But because we use 3D printing to develop this arm, we can make it for less than $500. Magnitude different. And so the plan for this is to add a gripper and allow you to start picking up objects, do cleaning, do senior care, even like education, labs and all that stuff. Okay, and then let me also show you how the robots are being made, right? I think we're all curious here with this 3D printing technology. So let me give you a quick tour of our facilities in California. Do we have sound or? It's okay. So these are the 3D printers that we are using
So
to...
this is one of our additive manufacturing farms.
there we go.
See
Oh. Let's try again.
Welcome to Omni Labs. We're excited to take you behind the scenes and show you how our robots are made. So one of the really unique things about us is that we make the bulk of our parts right here in California in-house. And so this is one of our additive manufacturing farms, and you can see, for example, a part being printed here. This is the back cover of the neck. And you can see this filament coming down and getting melted, and almost like soft serve being squeezed and sort of built up layer by layer to make the parts with all sorts of geometry.
So we design and build our printers in-house. We have about a couple hundred printers now in California.
This is part of our drive, our motor drive system, and then part of the more tube mounting. This is part of the neck of the robot. And we actually make this process really optimized and as efficient as possible. So we even wrote our own web-based software here to control and sort of manage the entire fleet of printers. And for production, we have 2 cycles a day and a night cycle. And we have these carts that we've designed. These are sort of our Kanban carts. And in these carts, every part has a place. And we know what the print name is and whether it's a day or night print. So we basically print and fill up these racks, and then we send them off to assembly, which is just 20 feet away. So we started there buying printers and modifying them for 24/7 use. But we actually now are moving to designing and building our own printers. And this allows us to improve on the process in 3 key ways. First, we can design to our needs. So for example, the build plate is much larger, and now we can have 1 cycle a day instead of 2, and you can fit a lot more parts on the print, as you can see here.
And we're using AI to optimize the printing process now.
More precise over time, and makes operation and maintenance much easier. And over here, you'll see an example of one of our large format printers. This is where we can print huge sections of the robot in one shot. It gives us a lot of design flexibility. It allows us to eliminate a lot of assembly steps because we can print such large pieces in one shot. And so we're aiming to be the first company to really bring this process to massive scale for robotics, and we'll continue to be building out all these printers over time. Here we are over in our assembly and inventory area. So here you can see some of the inventory that we hold for every robot. The carts come in from the printing clusters, and then over here, for example, are all the PCBs. So this is a brushless motor controller that drives the wheels of the robot. And over here we have the assembly stations, and we try to optimize all of them for being as lean as possible and as ergonomic as possible. Here we are at the final stage. So these are the fully assembled robots waiting for final QA and delivery. And come back next time and we'll share with you all the cool things we're working on and what else we're adding to the robot.
Thank you. Yeah, that's the end. So, we are building out these innovation hubs and bringing in Kambria to Vietnam with the hope that we can create this community of people developing AI, robotics on Kambria, and working with universities, to build out these labs, and of course, partnering with VietAI to bring in all the AI education and some of the robotic education to Vietnam as well. So really looking forward to more collaboration with all of you here in this room. So thank you. Do we have time for questions or no? Oh, no time. Sorry, guys. All right, I'll come back later. All right, and then, so for the next speaker, I would like to introduce to you Huỳnh Chip from NVIDIA. Huỳnh will attend our summit remotely.
Hello, 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 hello. Can you hear me? Hello? Okay. Hi everyone. So I have no idea who is there or who is listening to me. And I have no idea what's the reaction gonna be because I don't get to see you. So I'm Chip. Most of you might or might not know me as a writer, but I work in tech now. I'm on the AI application team at NVIDIA. In case you don't know what NVIDIA is basically the leading manufacturer of high performance computers. So the hardware you use for machine learning. So today, I'm gonna give this talk about career in AI. This is the one. Cool. I guess you cannot see it. Let me see. Let me try again. Cool. Okay, so I think let me see. So I think we try to go over a few points. So first is that why should you work in AI? The second is that who can work in AI, and the next is that if you want to work in AI, what should you study? How should you prepare for it? And the last is that how to get a job in AI. So I think like if you're attending this conference, there's no need to convince you why AI is important. But AI is basically essential right now. You can see AI in everything. A lot of I hate to cite this hype, but Andrew Ng, who used to be the lead researcher at Baidu and who was a founding member of Google AI, says it's like AI is a new electricity. It is that important. A lot of countries such as France, Canada, investing a lot of money into AI. France recently announced that they're going to invest $1.8 billion into AI. A lot of companies like Google, Uber are switching to be AI first, which means that AI is leading their technology. So the second reason is that like jobs in AI are pretty well paid. Recently, the New York Times had this article, a bit controversial. What they say is that they claim that PhDs fresh out of school earn between $300,000 to $500,000 a year. And Indeed, which is it's a job service, listed like the highest paid jobs every year, and machine learning jobs are constantly among top 10. And the next is that like it's almost borderless. Like it doesn't matter where you go to school, where you live, or where you come from. If you're good, you can get a job in AI. And let's take the example like Chiu Ching. He is also a member. He's also involved in VietAI. He got a job at Google AI after finishing college in Vietnam. You can also take a lot of courses online, like Coursera, EduX, Udacity. There's so many good courses that you can take from the comfort of your home, whether in Vietnam, in Africa. And the thing about AI is that a lot of resources are open source. Like all the papers are put on archive, all the code can be put on GitHub. So you can just like, if you're curious about something, you can always find online. So, so the thing is that I have no idea if you guys hear me well. I'm not sure if do or somebody can tell me that everything's going fine, because I feel like I'm just talking to the void right now. Yes, I'm just gonna continue. This is such a weird experience. Okay. So I hope that I have convinced you why work in AI. And there's this stereotype about only like genius hackers can work in AI. They have to be really good at something. But it's true is that like AI is just a tool. It's a tool that you can use it to solve any problems you're interested in. As an example, I'm gonna show you these are few of the people that I really admire. And they come from a background, like Christopher Manning. He was my professor at Stanford, and he's basically like one of the most influential people in natural language processing. His background is in linguistics. So David Ha, he's leading the Google AI lab in Tokyo. He used to be an investment banker at JP Morgan. Christine Payne, she was a musician. She played for San Francisco Symphony, and now she's OpenAI. So it doesn't matter whether you're interested in game design, whether you're interested in writing, you're interested in like anything. I'm sure you can find. You can use AI to like solve the problems you care about. So a question that a lot of people ask me is like, how to get into AI? Like, what should I study? And the first thing I tell them is like, you need math. AI is a lot of it is math. A lot of it is matrix manipulation. So first of all, you need linear algebra so that you can know matrix multiplication. You need to do calculus so you can do gradient. And also you need probability. So when you build a model to predict something, it doesn't just like tell you what is the best. Usually it outputs a distribution of the possible outcome, of probable outcomes. And you look at like, oh, so which outcome is the most probable? So yeah, so you need to do like, you need to know probability. A good thing is that I noticed that the Vietnam education system puts a lot of emphasis on math. So I usually see that Vietnamese students are really good at math, and when it comes to AI, Vietnamese have an edge compared to students from, say, the US or like Switzerland. The next thing is you need to know some coding because you need to implement model. One good thing is that most people in machine learning right now are using Python, which is a really easy language to pick up. If you want to be a little bit more hardcore, you can do C++. There's also a huge demand for people who can code well in C++. And you need to know some frameworks that can help you implement models easier, which is like TensorFlow or PyTorch. Yeah, you should do some practice like implementing models from like simple to complex. You can do something like a linear regression model. You can start with a linear regression model, and then you can progress to maybe like a recurrent neural network, or like a GAN, as in like generative adversarial network. So you know both a theoretical aspect, you know both a practical aspect. Now you need to keep up to date. AI is moving incredibly fast. There are like just so many things happening. So you need to like keep up to date with what is going on without getting overwhelmed. Sorry, I'm just like getting feedback from Ling to see whether the audio is good. So yeah, so to keep up to date, I usually use Twitter. So I follow certain people that I think they are doing a good job in the field, and they usually like have good discussion. So I just follow them and see what they are talking about. If you don't know who to follow on Twitter, you can go to my Twitter and see who I follow, because most of I follow are in AI, and it's just like after a while you can figure out like who is really like a good person like to follow. Another is like archive. So in AI, people don't republish in journals anymore because journals are too slow, and people want the results out there quick, so they put the paper on archive. So you can go through archive and basically see like on the latest paper like for free. And another resource I find really good is Reddit. You don't just go to any Reddit memes. So there's a subreddit like r/machine learning that has a really good discussion on the new progress people are making in AI. Okay, so of course, like what you should learn depends on the role you want to get. So there are usually like 3 different kinds of roles in AI. So first is researcher, which means you build new model. So to do that, you need to have really good theoretical understanding of math. So for researcher role, you will need a lot more math. I have known a lot of researchers who are not really good coder, and they can get away with it because they are good with theory. So another role is a research engineer. It's very popular with Google AI or Facebook or like basically any AI lab. They're like engineers who help researchers build models. So you need to understand math to know what the model is about, but you also like need to have really good coding skills so you can like turn this model into reality. Another type is application engineer. So like you don't really deal with research, but you build you take the research and try to bring it into production, to bring it to end user. So you need to know how to scale a model. You need to know how to like do inference, but less math, but more coding. Okay, so next is to my favorite topic, how to get a job. I think when I get to Vietnam, I get the questions a lot, like how's the job, to get an apartment, when you're getting married and stuff like that. I hope you can relate. I don't want you to force the impression that like AI is so hot, it's so easy to get a job, everyone should go into AI because you can make shit ton of money. No, it's not that. Like AI job market is fiercely competitive. The reason is that like everyone is trying to get into AI, and there's just not that many jobs. And also like this estimation by like Element AI, they said like only about like have like millions of people taking AI courses, but there are only about like 10,000 people actually know what is going on. So you don't want to be just like one of those million people who just take courses and not understanding the importance, like the significance of things you're learning. I have chatted with a lot of recruiters from with Google or like even with my company in NVIDIA, and they told me that out of all resumes, only 1% of the resume received get to the interview process, and out of all the people they interview, only 5% get a job offer. So it means that if you get 10,000 resumes, maybe 100 of them will get interviewed, and about like out of those 100 people, maybe 5% eventually get a job. It's 5 job offers out of 10,000. It's just like really, really insane. The interview process, you guys are pretty familiar with it, but I'm just gonna go over it anyway. Varies company to company, but it's usually it follows the same skeleton. So for this first screen, when the recruiter or some team member is calling up and say, that should get to know you, what should get to know whether the background is going to be a potential fit for the team, whether their interest aligns with the company's interest. And after the phone screen, you're okay, you're not a psychopath, it's going to move you to coding challenges or interview. It's really done online. So yeah, so code pad or something, so they'll give you some problems and you have to do live coding to solve the problems. So next, after you pass on this, you can go to an on-site interviews, which means the companies will bring you to the office. And you have a day-long interviews with everyone. So it can consist of anywhere from 4 to 8 interviews. When I interview Google, I had 10 interviews. It's a really long process. And after all of that, we have a hiring committee gonna meet and decide whether you pass on the requirement to get a job. So yep, but don't fret. It's actually doable to get a job in AI. So there are a few tips. So the first thing, you have to make the resume stand out. Given the insane amount of resumes that every company receives, if you just have a normal resume, you finish school, you just all the coursework, you're not gonna stand out. So I can speak from my experience. Recently I helped my team because our team is very new, so we are recruiting a lot. And I got a lot of resumes. I got hundreds of resumes, and I got a lot of resumes from really good school like Stanford, Harvard, MIT. Oh, these people just they didn't do anything outside coursework, and we just discard as a resume, even though they went to really good school. So how do you make yourself stand out? You have to go. What my manager said is you have to go above and beyond. You have to be. You have to show the pattern what you are asked. So first, you can do cool projects. I've seen people doing really cool projects, as in one thing I do is as in how to detect whether somebody is drunk for the text messages. Or my friends and I did something in college which got pretty popular, was that based on people interaction on Twitter, we can detect echo chambers. So people with the same political affiliations. So we can predict with pretty high accuracy just from somebody tweeting that whether the person will be Trump supporter or not. Yeah, but doing things is not enough. If you don't publish what you've done, there's no reason to know what you have done. So you can publish through blogs. I love technical blogs. So when somebody write a technical in-depth blog post, it not only shows that you understand, you know what's going on, you understand concept. It shows that you have good communication skill to be able to explain the concept. And communication skill is extremely important getting a job. You can still write archive papers. You can still just because they have really good. I've seen their code on GitHub and have been so impressed. I reached out to them asking whether they'd like a job with my team. So you can also join competitions. I hope you know Kaggle. Kaggle is where they post some certain challenge usually in data science and machine learning, and you can compete. And people who have won Kaggle competitions are usually considered pretty good. If I see a candidate, a resume winning a big Kaggle competition, I would be pretty down. I would be very interested in interviewing the candidate. A lot of conferences like NIPS on New Rips now has a competition track where you can just enter and compete with other people, which is so great. Even so, hackathons or competing in public benchmarks. Another way is that you should contribute to open source project. So even and my friend got a job offer because he contributed to a TensorFlow project. I also did some open source projects, and this guy who committed a really detailed, a very meaningful contribution. It was like, wow, he actually really knows, he has really good coding discipline. So actually also again reached out to him. So yeah, so second step is you have to prepare for technical interviews. Like you can be really good, but if you are not prepared, like you're not gonna be able to show how good you are. So technical interview is just like any other test. Like if you take SAT or GRE, you pretty have to prepare for it. So the same, like if you do a so like if you go to technical interviews, you should probably prepare for it too. And it's a very long process to prepare. It should take at least a month. So you not only have to prepare for the like normal software engineering questions, you can check out the book like Cracking the Coding Interview. You should also like stock upon the machine learning exercise, because the recruiter might, or like the team might ask you to implement machine learning models. You also need to have the theoretical understanding, because we understand like, oh, you say that, oh, you have worked with convolutional neural network before. We probably ask you to explain in detail, like what does it mean, why you do that. So you need to understand like everything that you did. And it's a long process. Again, like it's a big time commitment. You can just show up and expect to get through it. You might actually, if you're a genius, maybe, but maybe like only 1% of people are that good. Okay, so the next thing is do internships. Internships are like extremely important, and so I think recent years is that more and more Vietnamese students are doing like meaningful internships. But in the US, it's pretty standard. At Stanford, when I went to school, like almost everyone did internship. It's very rare to see students not doing internship for a summer. So internships help you like understand what you want. You might think that you want to work in AI, but then what if you start working and realize that you don't like it? So internships help you understand what you are getting yourself into. It can also help you understand and compare different companies to see which one suits you the best. And different companies have a huge different culture. Like NVIDIA and Google and Facebook all have very different cultures, and you might like one company more than the other. And also, an important thing is that internship to full-time conversion is much easier than getting a full-time offer. Like internship interviews are like 3 times easier than a full-time interview. So what you can do is that you get an internship, and then you do one internship, and then you get a returning offer for a full-time job at the same company. So it's easy, much easier. So NVIDIA, our main pipeline for new graduate candidate is through internships. So we highlight mostly from people who have done internships with us. Okay, and some tip, get referrals. So because there's so many people applying for jobs, getting referred by someone in the company will help move the resumes like to the top. So it might be easier for you to get an interview. It's not gonna get you a job if you're not good, but it will help you get a foot through the door. On the online profile, so it's pretty standard for recruiter nowadays to get a resume and do a quick check on your life. You shouldn't have any drunken photos. You shouldn't make some like racist and sexist remarks. You should not bully people online, because people would find out. Another tip is that like a lot of people, when they do coding interviews, it's like, okay, I'm gonna do Python, before even knowing what's the problems that the recruiter wants them to solve. So one tip is that like you always hear the question first, ask on the clarification about the problem before deciding what language would be the best to solve that problem. And yeah, another thing is the last one is to be honest. Like you should not pretend to know things that you don't know. So when I interview people, like one red flag I have is like when people just throw things like, oh, you use BERT, you use like transformer, and then I ask them, okay, so how do you do that? And they're like, I actually don't know. I just heard it somewhere. Like, then why didn't you bring it up? So if you don't know something, just don't pretend and don't speak like you have done it before. Okay, that's all. So if you have questions, shoot me an email. This is my email. I also have this blog, quinchit.com/blog. So I have like some posts that might be relevant to you, such as career advice for recent computer science graduates, survival a survival guide to AI courses at Stanford, but it's like also applicable to other courses elsewhere. Okay, that's all. Thanks. Have a good day. I wish I could see you.
Hello. Is this working? Yeah, great. Okay, so that was fast. 3 presentations done. Now we're going to have a tea break. So we would like to invite you like outside. We have refreshments and fruits ready for you. We will adjourn in 15 minutes. So at 10:30, we'll be back in here for the second session on AI and academics in academia. See you in 15. Oh, and one more thing. Since we've been going very fast, you weren't able to ask questions.
Tháng 3 năm 2018, nữ doanh nhân Văn Đinh Hồng Vũ cùng ứng dụng học phát âm tiếng Anh Elsa Speak đã gọi vốn thành công vòng Tria trước Syria với con số 3,2 triệu đô từ Silicon Valley. Sau gần 3 năm ra đời, Elsa Speak đang có những bước tiến mạnh mẽ. Ra mắt vào năm 2016, Elsa Speak là công cụ đắc lực cho người học tiếng Anh trong việc học nói, nghe, giao tiếp. Nhờ vào công nghệ Speak Recognition, phân tích giọng nói chính xác và phản hồi thông minh để giúp người học phát hiện lỗi sai trong phát âm đến từng chi tiết và hướng dẫn sửa lại một cách chuẩn xác nhất. Đến nay, ứng dụng có gần 4 triệu người dùng trên 101 quốc gia, trong đó có hơn 1,6 triệu người dùng tại Việt Nam.
Công nghệ này họ có một cái khả năng rất là đặc biệt, nó là nghe được các bạn nói từng từ, từng âm một. Và sẽ phân tích là cái âm nào bạn sai và âm nào bạn đúng. Và nếu như âm sai hay âm đúng thì mình sẽ phân tích là bạn sẽ phải thay đổi khẩu hình miệng, khẩu hình lưỡi như thế nào. Với công nghệ mình có thể giảm chi phí này, như hiện giờ tụi em chỉ tính tiền khoảng từ 60.000 một tháng. Dù là các bạn đến từ hoàn cảnh nào, các bạn cũng có thể học nói được.
Nhân ngày Nhà giáo Việt Nam 20 tháng 11, Elsa sẽ phát động chương trình Thầy cô Việt dạy tiếng Anh hay để có thể thực sự giúp người Việt nâng cao trình độ tiếng Anh của mình ngay từ trong trường học.
Deep learning is this branch of machine learning loosely inspired by how the brain works. We have had experience building software for deep learning over the last few years.
Although it was initially a research project, we've since collaborated with about 50 different teams at Google and deployed these systems in real products across a really wide spectrum of areas. Today, it's used heavily in our speech recognition systems, in the new Google Photos product, Gmail, in search.
We've really taken all that experience and built that into TensorFlow. TensorFlow is this machine learning library that's used across Google for applying deep learning to a lot of different areas.
Doing both artificial intelligence research and deploying these production models. They're really powerful at doing various kinds of perceptual and language understanding tasks. These models are able to actually make it so computers can actually see and are actually able to understand what is in an image when you're looking at it, what is in a short video clip. And that enables all kinds of powerful product features.
Machine learning is the secret sauce for the products of tomorrow. It no longer makes sense to have separate tools for researchers of machine learning and people who are developing real products. There should really be one set of tools that researchers can use to try out their crazy ideas, and if those ideas work, they can move them directly into products without having to rewrite code.
On the research side, the goal is to bring new understanding to existing problems, advance the state of the art on existing problems, understand new problems that weren't considered before. Then on the engineering side, the goal is to take those insights from the research community and use them to enable products and product features that wouldn't have been possible before.
Part of the point of TensorFlow is to allow collaboration and communication between researchers. It allows a researcher in one location to develop an idea and explore it, and then just send code that someone else can use on the other side of the world.
We are making it a lot easier for humans to be able to use the devices around them. We think having this as an open source tool really helps that and speeds that effort up. So we expect developers to be able to do a lot more than they can do today.
We think we have the best machine learning infrastructure in the world, and we have the opportunity to share that. And that's what we want to do here.